Hello everyone. In my last video, I attempted to show you how to draw the bohr-rutherford diagrams for various elements. So I was talking about carbon and then moved into the Lewis dot diagrams. And then I wanted to show you how to draw this for sodium, how the different orientation of the valence electron can be situated around the chemical symbol for the element, and then how we deduce the number of protons, neutrons, and electrons. For some reason in the last video, this whiteboard didn't show up, although you can hear my explanation for the last 5 to 10 minutes or so. So I just wanted to briefly go back over as a part 2 explanation and show you one more example. So here again, we have our bohr-rutherford model for sodium, 11 protons, 12 neutrons, and all of the total number of electrons for these energy shells. Likewise, we have the chemical notation for sodium written over here on the right, and we have the different orientations for the valence electron in the Lewis structure. We have that one dot representing one valence electron corresponding to the group number 1 that sodium is a part of. So I'm going to do a new example now for a different element on the periodic table. So let's say that for the purposes of this video, I am going to just do something very quickly to reiterate the point that I'm making and select oxygen. So we're going to create a new space. Okay, just make sure we're on the whiteboard. Select our pen. And we are interested in creating the bohr-rutherford model for oxygen. So I mentioned in the last video that the atomic number for oxygen is 8. And the atomic mass for oxygen is 15.9. Now remember that we're going to work with a whole number, so we can just round up 15.9 to 16. Okay, so 8, this is going to be the atomic number for oxygen, and 16 is our atomic mass. So to write down the chemical notation for oxygen, we're going to use the chemical symbol for oxygen from the periodic table, followed by writing the larger number on the top and the smaller number at the bottom. So the chemical notation for oxygen is O, 16, 8. Now recall that the 8, which is the atomic number, tells us that we have 8 protons for this particular element in the nucleus. And also, the number 8 tells us that we're working with a total number of 8 electrons. What does the 16 tell us? Well, this number 16 is going to help us figure out the neutrons in the nucleus. All we have to do is take 16, subtract from 8, and we will figure out that number of neutrons. And you might have already did that math. Oops, let's make that a little bit better looking. That your 16 minus 8 equals 8. And it's nice when you use whole numbers, because then you can just do this math in your head, and therefore we have 8 neutrons in the nucleus. So getting to our bohr-rutherford model, remember that we are going to put the protons and the neutrons in the center, and the total number of electrons, so that 8 electrons, is going to be orbiting around the nucleus. So it's kind of like how the planets are orbiting around the sun. Think about the solar system. So let's go. So we'll just quickly switch up the colors. And let's see here. Write down same information. So we have 8 protons. We have 8 neutrons, so 8 and 8. And then we're going to draw the orbit, or the nucleus, right, where those protons and neutrons are located. And the next step is now to draw the first energy shell, followed by the second energy shell, and then fill in the dots where the electrons would be. And remember, again, these electrons are total number of electrons. Okay, so 1 and 2. And I'm just going to switch to black to make it evident that these are the electrons. So we need 8 electrons total. Remember, 2 go on to the first, and then the rest of the electrons go on to the second for a maximum of 8. So 1, 2, right? Watch your count. So we've used 2 so far. 8 minus 2 is 6. So we need 6 more. So that's 1, 2, 3, 4, oops, 5, 6. Well, that was not a good one. Let's undo and try that again. Right? And if you lose track, count again. Right? We need 8 electrons. 1, 2, 3, 4, 5, 6. Now we're going to start pairing up. 7 and 8. So we have 8 electrons. Now we need the Lewis dot diagram for oxygen. So we'll draw an O. And remember, the Lewis dot diagram is only interested in the electrons in the outermost orbit. So in this last orbit, circle all the electrons, and that will tell you how many dots you need on oxygen. And count them. So we have 1, 2, 3, 4, 5, 6. Now you might be thinking, how do you draw these 6 dots? Where do they go? You just draw 6 random dots around oxygen? Well, no. If you see anything in pairs of 2, keep those 2 dots together. That will be important later when we talk about ionic and covalent bonding. So the 2, as we say, pairs of electrons will stick together, and these 2 lone pairs of electrons will stay by themselves. So what does that look like on oxygen? Well, we'll have 1, 2, 3, 4, 5, 6. So oxygen has a total of 6 valence, so we'll just say 6 valence electrons. And this is the Lewis structure. So we have a Lewis structure, so we'll say this is our Lewis structure for oxygen. Over here we have, again, the bohr-rutherford model. And here we looked at the chemical or nuclear notation. So this was another example. Again, number 8 was reflective of the atomic number. I got that from the periodic table. And the 15.9, which was rounded up to 16, was corresponding to the atomic mass of oxygen, which is our element, with the chemical symbol O. So I hope that was another helpful example for you. Take care, and I will see you again when we talk about chemical bonding.